What if the ocean itself could become a giant natural battery, charging up when the sun shines and the wind blows, then discharging clean power during calm, dark nights? This isn't science fiction. Across coastlines and continental shelves, engineers are turning the deep sea into the world's most unexpected energy vault, the ocean battery. Unlike lithium-ion cells or pumped hydro on land, ocean batteries exploit the immense pressure and volume of the deep sea to store energy mechanically. One leading design, developed by Dutch startup Ocean Grazer, works like this. When excess renewable energy is available, say from offshore wind farms, it powers pumps that push seawater from a flexible, seabed-mounted reservoir into higher-pressure storage bladders anchored deeper below. The ocean's natural hydrostatic pressure acts like a spring, compressing the water and charging the system. When electricity is needed, the process reverses. High-pressure water is released back through a turbine, spinning it to generate power, just like a hydroelectric dam, but submerged, silent, and invisible from the surface. Other concepts take even bolder approaches. Gravity-based systems lower massive concrete blocks into deep trenches during surplus generation, then lift them to produce power on demand. Compressed air energy storage, KES, injects air into underwater chambers. The ocean's pressure keeps it compressed until release drives a turbine. Thermal batteries use cold, deep seawater to store energy as temperature differentials, later converted via heat engines. For island nations and coastal communities, ocean batteries solve a critical flaw in the renewable revolution: intermittency. Solar and wind are abundant, but not always available. Batteries on land are expensive, resource-intensive, and space-limited. The ocean, by contrast, offers near-infinite volume, natural cooling, and built-in pressure, free infrastructure provided by physics itself. Pilot projects are already underway. In Norway, a submerged energy storage unit off the coast of Bergen is being tested alongside floating wind turbines. In Japan, researchers are exploring deep-sea caves near Okinawa to stabilize grids vulnerable to typhoons and seismic disruptions. And in the Caribbean, where hurricanes can knock out power for weeks, ocean batteries could provide resilient, decentralized backup, no fuel required. Critically, these systems are designed with marine ecosystems in mind. No toxic chemicals, no rare earth mining, minimal visual or acoustic footprint. In fact, the structures often double as artificial reefs, fostering coral growth and fish habitats. Of course, challenges remain: corrosion, deep-sea maintenance, and high initial deployment costs. But as offshore wind booms and climate pressures mount, the deep ocean is emerging not just as a source of power, but as its silent, steadfast guardian. Because in the end, the sea doesn't just give energy, it remembers it, and when we need it most, it gives it back.